Hey, thanks. Okay, so I'm going to continue my fine tradition of giving ScalaSyd talks that are tangentially related to Scala only. And this talk came about purely through accident a few months ago, where I used to run a company that built API management software. I kind of rage quit that a couple of years ago. And then somebody asked me to do a talk at API Days. And my current job that I've had for the last 3 years almost doesn't do web at all. So I had to come up with a hypothetical company that did web, and I was going to talk about APIs. But I thought it'd be kind of an interesting ScalaSyd talk in that it's for people building software and building reliable software, and something I like talking about, so I thought I'd talk about it again. But to make it more Scala-y, I thought that you can do a transformation layer. So if you really want to hear more Scala tonight, I suggest every time you hear the word API or HTTP, replace it with the word flat map. And every time you hear or see the word failure or error, replace it with null pointer exception. Okay? We're programming on the JVM. Oh yeah. So, something might work. Oh, yeah. So, Douglas Adams wrote a book in early 1992. It's part of the Hitchhiker's Guide to the Galaxy series. It's a pretty average book, but it turned out that, as you'll see from a series of quotes through this, it's just sage programming advice. Yeah, don't try to beat the fools. Well, accept that things are going to fail, and we'll talk about it a little bit as we go through. So how did we get here? How did we get to the point of failure? So first of all, we have an idea. This could have been an accident or it could have been intentional, but we built an API for that idea. When I say the word API here, I'm specifically talking about a HTTP API. Somebody's going to call it using a web browser or using curl or some other library. So we accidentally built an API, and then we accidentally got a user. And then we realized that we should store some data because having it in memory in a server is probably not a great idea. So now we have a database. Then we got 3 users. And we thought, oh, well, now they're getting really annoyed. They can't reset the password. So now we start sending emails, which kind of happens. And then eventually we start caring about these people's data, that actually use the system, and maybe even they paid us or something. So we have a backup of the database, which is useful. And then we get some more users. Maybe we're becoming successful, or somebody's forced to use it. Anyone who works in the enterprise, you've been forced to use something. That's my API. But as more people started using it, it got slow, so I just added some caching. I got a cache now. And then it started breaking all the time because we added a cache. So I added some monitoring to work out when it broke. Then lots of people used it, again, probably through force, because nobody would do this voluntarily. So then I'd cloud, I don't know. Somebody come onto my team and there's like some MongoDB or something down here. I don't know, yeah. As I said, force. Everyone's forced to use this. Don't have to justify any decision. But then, because it's so popular, then we need an architect astronaut, which is actually my job, which is kind of funny. So one of these guys comes in, and yeah, microservices. Whoops. And yeah, then they go away because they get bored. They've created their mess and they want to leave it. So then the marketing people come in. But marketing people come in and then they wanted to cash in on our API because APIs are like cool marketing thing these days. So basically they wanted us to start like charging money for this API, which really led to all sorts of stuff, which just led to fire. So what happened here is just an innocent mistake. Series of unfortunate consequences, which all led to building a really, really complex distributed system for sending strings, right? But this is what happens, right? Failure is kind of inevitable. Things get more complex, things break. As soon as you're talking over a network, things get really hard. And people act like they don't, but they do, always. So I'm going to talk about a few different things tonight, and it might seem a bit sporadic, hopefully not too sporadic. But the first thing I want to talk about is how systems fail, or how systems null pointer. Okay. So systems null pointer in a bunch of different ways, but the particular ones that I like are the ones where I can learn from somebody else. So I'm going to talk about a few system failures and possibly some experiences that we can learn from other people, because we wouldn't want to make a mistake. something like this. Hopefully we're the learn part, but not always. Again, terrible book, but amazing. It applies to programming in every sense. The first type of failure is the crash, right? We have a bunch of things. This is some point after the astronaut architect. So we have lots of services. And one of them fails. Yeah, it fails, goes down. Somebody restarts it, or it restarts automatically, even better. Then it comes back alive, and our system comes back up. This never happens. So we're going to talk about more interesting ones. Systems generally don't fail cleanly, so let's talk about those ones. So the first type of not failing cleanly is cascading failures. That's a pretty simple situation. Something fails, but of course something depends on that, so they fail. And then something depends on those, so they fail. Something depends on those, so they fail, until pretty much most of your system's gone. Probably everything. I think this is a pretty good example, I think, to learn from for various reasons, but it's quite a while ago now. But Amazon Web Services is fairly reliable, although their status page is awesome because I'm pretty sure it's just a static image of green. I've never seen it change, even when it's gone down for like days. So it's all relative, but they're not too bad, right? Basically a huge Amazon outage. So all it was caused by was a small number of EBS volumes. So that's basically like an online hard disk, started responding slowly. And all of a sudden, all their EC2 instances that were talking to these EBS volumes started responding slowly. And then all the services that were running on those and talking to those started responding slowly. And eventually everything became stuck. And it took out an entire data center and got really bad. It was pretty interesting because this one thing was just a single performance issue that got out of control. So don't listen to programmers. Well, don't listen to functional programmers. So I'll clarify that really simply, is that I'm just sore because I was really unprepared for tonight and Oliver took my functional programming fodder. Sorry. Okay, so asymptotics matter probably more than performance, but yeah. So as we get bigger, we don't want it to get slower. And a failure is the other thing we learn here is a failure is indistinguishable from a slow response. So yeah, just think about that when you're building your programs. Next thing is a chain reaction. It's kind of like a cascade failure, gets mistaken all the time, but I'll try to explain the difference. Hopefully it'll make sense. So if I have some service that I've got 8 instances of, and I'm load balancing across that, that means that each of these instances is getting 12.5% of traffic. If one of those goes down, and I'm left with just 7 instances, the load balancer is going to detect this in some way, and then I'll end up with 7 instances that have roughly 14% traffic. If another one goes down, it drops down to 17. So it doesn't sound that bad, but if we turn that into a request number, so if we're getting 100,000 requests, that becomes 17,000 requests. But if you look at the number of requests per server going in, that's actually close to a 40% load increase. So if we lose 4 servers, 4 servers going down results in a 300% load increase on each server. And effectively what happens is that as one thing goes down, cascades as well. But this is a kind of chain reaction situation that load begets more load, and we get failure. Generally the difference between one of these failures, like the chain reaction and the cascade failure, is generally chain reactions happen inside of a service or inside of a service ecosystem. Cascades kind of are generally across your infrastructure. So capacity skew, this is something that I run into quite regularly in my environment. It's probably fairly unique in that I do lots of batch processing, so it comes up quite a bit. But basically the problem here is that if we have a bunch of services that are all receiving equal load, but for whatever reason, some of those start receiving more load than others. This can happen accidentally, but what generally happens is that any skew here generally leads to more skew, and then things crash, and then we get one of those other type of failures. So these are all fairly closely related, right? But these are the types of things that happen. So Twitter's got a good example for us, again, a long time ago. We'll say it was before the Scala. It probably wasn't. But basically what happened is that they were really prepared for the World Cup. So Soccer World Cup, large number of people use Twitter, and they thought this was going to be our year. We're going to have huge amounts of traffic. We're going to prepare for it. They did a whole bunch of capacity planning. They built out their network infrastructure. They rebuilt their messaging architecture. A whole bunch of awesome stuff. But what happened is that their load wasn't evenly distributed. So they'd planned out all these networks, and it turned out that one of the networks was receiving just a little bit more traffic than everything else. And of course, that little bit more traffic, because it wasn't evenly distributed, broke that subpart, which broke another part, which broke another part. And the fail whale that we don't see very much anymore hit pretty hard. The next type of failure that's kind of interesting is the self-denial of service. I've hit this one again recently. This is an old example for me. Basically, you have a bunch of clients, you have some servers, it makes some calls, and then it makes some more calls, and eventually everything goes really wrong. It's good that your clients make calls. It's bad when you misconfigure them. But I'm going to tell you about a slightly painful experience that I had probably almost 8 or 9 years ago now. But I was working a place that had a very expensive service. It was very simple, but had 100 million plus users, lots and lots of money flowing through the system. And they were really simple services, but the clients were thick clients. They were things that ran on Windows XP. One of my ex-colleagues is laughing at me in the front row right now. But it did something really cool. There was a single call, and you could call this on demand, like as in make that call, or there was every now and again there was a periodic check, am I okay, kind of like a heartbeat. Over time, there were more and more clients, so they ended up with big check 2, check 2Z, lack of consistency or something like that. But eventually this led to some high load, okay? And people thought that they would sit down and they would solve this. And they knew that the old programmers were terrible, so they would just do it in a totally different way. But the old programmers weren't as silly as they thought. So what the people who thought they'd solve this problem by did is that they all got together and said, let's have a look at our monitoring. We've got monitoring, let's use it. And they worked out that Sunday evenings, 6 o'clock, hardly anyone used their computer. It was dead quiet, almost no traffic. So what they did is they configured the clients, all of them, to call home at exactly 6 o'clock. Yeah. It didn't really work out well for anybody. Yeah. Oops. But yeah, and they were thick clients, couldn't be updated. That happened forever. Anyway, so don't do that. Self-denial service bad. A slightly more interesting one that I've hit, maybe not as interesting, but I've hit it recently, is that we use Amazon pretty heavily, use S3 pretty heavily. The one thing that my company does is copy like bits from like one part of S3 to another part of S3, like lots. And some of those jobs are important. Some of those jobs are not important. But we are very easily able to break Amazon. Yeah, it's broken. Basically, we create our own self-denial of service attacks all the time. Is that if we let a job run out of control with unrestricted uses, it will break Amazon. And that turns out to be pretty shit. Sorry. It turns out to be really bad. Don't do it. Cool. System collusion. Okay. So this is a more interesting case, I guess, where you have two systems, two little boxes here. They're both working perfectly. They work awesome. But together, when they act together, the output is something catastrophic. Generally some sort of failure, generally leads to some sort of other cascading failure, etc. Facebook had a really, really good write-up on this. It's a really good example of a kind of outage report. But basically what they had was a link imbalance. So basically they have a service and a database and lots of networks pipes between it. So this service got a lot of traffic. It's Facebook. People use it. And what happened is that they had a little client-side load balancer here, and it would pick which link based on how much traffic it had received. So if a link had received less traffic than something else, then it would send more queries there, right? So kind of balance things out. Seemed to make sense at the time. But what actually happened is that anything that caused one of these links to be slow, so if there was a network issue, configuration issue, or just a slow query, this one got slower, hence it had less requests. And so let's send more requests to the really slow link. And eventually the client-side load balancers ended up sending all the traffic to the slow one. And it took them months to debug this, and it's quite an interesting thing. But again, these sort of unexpected things happening, failure is somewhat inevitable. Cool. Systems couldn't correct themselves. Yeah, it broke. Cool. Yeah. So what do we do about this? We'll let everyone think about it for a second. I like this quote again. Oh, slightly too much Hitchhiker's Guide tonight, but I like my code working, but I really, really like being able to sit at home and not think about it. Like, that is the best feeling. I'm thinking about not thinking about code. It's great. So, how do we get to the point where we don't have to think about thinking about code? The first one is testing. And this is really, really obvious. Test everything, all that sort of stuff. More interesting things that I kind of probably want to point out is that the best yardstick I've had for the most valuable testing is the one that you don't want to do. So if you have a test that is hard to write, requires extra infrastructure, whatever it is, if you're sitting there going, oh, I'm a tester, I write tests all the time, like all these developers who don't write tests, can't work with them. You get to the test that you don't want to write, that's the one you need. That's all I'll say. The types of things that this normally is performance testing, scalability testing, stability testing, so soak tests that run for days at a time and do spike testing in amongst that. They're really complicated, they're really painful. Requires lots of infrastructure quite often to set up. They're the ones that you help. There are lots of tools that help with these sort of tests. Firewalls that you can artificially slow down network, load testing tools, monitoring tools, things that just randomly break stuff. All these are good. Cool. After we've tested everything and we kind of know that everything in our test environment works, the next thing is we want to measure everything. Again, I've probably talked about this at ScalaSyd even before. Should have traceability back to code and data from every computation. So if it's services, then that means you probably should have either a service or a database or something that collects traces so that if you're going to call across multiple things, you know a single call trace, you know what versions of the code, you have some stats about that call. All I'll say about that is statistics work. So being able to have these numbers available, even if you don't use them effectively at the start, eventually will pay off. So that's pretty useful. Cool. Yeah, look at that. And then if statistics really do work and you start collecting them, eventually you'll be able to take corrective actions automatically. So when something's slow, you shut it down, you start up a new one, whatever that is. The numbers help. Cool. Oh yeah, probably been talking for too long already, but now I'm just going to start my talk. Okay, sorry. So production and development, copied production quality data, automation environment, lots of testing. I hope everyone does this already, so I'm not going to talk about it. But my favorite topic always is development in production. So this is my favorite thing, and it's not always true. Everyone who works with me knows it's not true at all, probably. But this is my goal. This is my goal for life, is being able to ship any crappy code. Doesn't matter how bad it is to production, and have faith that I can go home and be sitting in my beach house or whatever it is and not think about that code. So what exactly does that mean? It means if I have an example service, service that has some sort of query service, but it's a batch query, so it goes to the data store and records that we're going to take this query at some point in the future. Eventually, something will generate it and store out a report, and then maybe somebody else later on can come back and call and get the result. Okay, so it's a series of calls, involves a number of services, so it's kind of somewhat complicated but necessary. So if I want to run experimental code in production, the first thing I need is split environments. That means that when I have one of these, what I actually need is this query service in production is just one view of the world. What I really need is a proxy that can kind of be very intelligent about how this request is going to be processed. So basically, I want to be able to spin up multiple services at different versions and run them together, send the request to both or send the request to one. Potentially, what we're trying to do at the moment is being able to have this proxy be smart enough that different users specifically get different requests. So A developer can check a few tick boxes and get their crappy, intentionally broken service, but nobody else gets it, for example. That would be great. Once we've got this infrastructure, then we can start doing tandem deployments. So running two services in parallel, getting both the answers. If they're consistent, then the new one probably works like the old one, and we can eventually shut off the old one and start with the new one. And then we can get to stage deployments where we start with some small subset, roll those versions. Once that's up, then we can go out and kind of spread it. So I went through that really quickly, and I went through that really quickly because every time I do it, everyone goes, yeah. And then everyone goes, that was really abstract. I have no idea what you said. So you can just ignore it if you want. So I'm going to talk about how we actually do it. And hopefully this will be informative for some people. The reason why I don't normally talk about this is because it's really specific to our environment. But being concrete will hopefully help. Yeah. So all of our infrastructure runs on Amazon. That's relevant because I'm going to use Amazon words. If anybody wants to ask me what I mean, just yell out. I'll try to explain it as I go. Hopefully it's not too complicated. So we have 3 services. These are real services. Some of them aren't finished, some of them aren't live, but these things exist as projects. So I'm going to talk about them with real names so that I don't get confused. But Manna there is somewhat of an Animal Farm theme here, if anybody knows. But Manna is our front-end application, serves up some HTML, talks to some other back-end services. Napoleon does some reporting. Boxer kicks off batch processes in an ideal world. So how do we actually deploy? So we have a thing called Baton, which is just this bit of the conductor, apparently. So Baton is a service for deploying code. It sits over the side here. And what it's going to become responsible for is controlling that proxy. So if I go right back, I said, have some proxy, hand wave. So what the Baton service does is it actually controls how this proxy is going to work at any given time, and what services are running. So we use Amazon EC2, and how we do this is that we have autoscale groups, which is basically a collection of services that run, a collection of servers that run together, all with the same configuration. So each of our services is actually a single autoscale group might have multiple servers in it, might have one, but they have some sort of consistent configuration. So that means like one version of that software, that one has one version of Boxer, that one has one version of Napoleon, all these instances. And then through some APIs, we can say that we do client-side load balancing so that Manna needs to call Napoleon a Boxer. It will be able to establish a little table that looks very much like this that says, I know about 2 boxes. One of them is at .1, one is at .2. In our real implementation, there is several extra details here that are really important. How much weight is associated? Do we want to send exactly half of our traffic to one, or do we want to send 90% to one or another? This doesn't talk to any of our services. It just scrapes Amazon EC2 tag APIs and says, what do I have available? What can I call? And we manage it that way so that we don't have to run any moving parts. So Baton then detects a new piece of code. And I'm not sure how this is going to work. Somebody... is it going to... I don't know if this is going to work, so... Okay, so I'm going to do a build, and... I don't know what I can show. Okay, so I'm going to do a build, and at some point, you can see that Baton has actually been working at some point, and that Baton, a couple of hours ago, deployed a new service, which meant that it started up a service, it started up a new machine, stopped an old one. So in 10 minutes, maybe 10 or 15 minutes, we'll come back. Hopefully I'll be finished my talk, and Baton will have actually done its work after I've explained how it works. Hopefully. Oops. This is slightly risky. I was going to do a commit, and somebody just talked me out of it. It's all right. Committing's great. The backstory of committing being great is that I barely write code anymore. I just sit around and be overhead. So my one chance to commit might be in a talk. It'll be great. Okay, so Baton has detected a new piece of code, which is what's going to happen in a minute, is that build's going to run, it's going to produce a new version. Baton's going to see that new version. So what Baton is going to do at that point in time is it's going to start a new auto-scaling group, and that auto-scaling group is going to be seeded maybe with a single instance at that time. And then a few minutes later, Baton is going to come along and say, look, okay, I think that everything's good, and it will become available to Manna. So that service is up, it'll get Manna will now know about an IP, and so then I'll get 1/3 of traffic to here, 2/3 to here, the old version, and then eventually it'll go, okay, things are looking okay, I'll start up another instance in this autoscaler group, and then eventually it'll start taking ones out of this autoscaling group until it disappears, and we end up with our new service. So hopefully that's what's going to happen in the background while I keep talking, hopefully. Okay. So the point of all this was that there's a whole bunch of stuff that we can do to try to prevent failure from ever reaching production. So testing, great dev environments. Once things are going to production, put them kind of tentatively into production so that you can take them back out quickly. But we also want to control failure. So once it actually happens, which will always happen no matter how careful you are, what are techniques that you want to use inside of your code to make it less of an impact? So I'm going to have a drink. You can read that. Oh, it's great, right? Okay. So I apologise to anybody who's seen this before, but I think it's worth repeating. So this is sniped from a talk that I gave at Lambda Jam in Brisbane a few months ago. But bear with me if you've seen it before, because I'm pretty sure most people haven't. Okay. So bad things can happen. So I live in a neighbourhood. It has houses. I don't really. I live in Sydney. But the probability of this house failing, and in this case failing means catching on fire, because that's how houses fail in this area, is 0.1. So that means that I have a 1 in 10 chance of my house catching fire. Okay. So, being a programmer, what do I do? Redundancy. Redundancy is great. If I have 10 houses, the chance of me sleeping tonight, what's that? Yeah, something like that. So I have 10 houses. I really like sleeping, as I mentioned before. I like sleeping while I'm not thinking about code. Yeah, so I definitely want to sleep tonight. So I get 10 houses in case one of them fails. Now, one of them fails, okay? So the probability of an individual failure is 0.1, right? So in my programmer statistics, which are never trust programmer statistics, I hire statisticians to do that, is the probability of system failure is like 0.1 to the 10. So that's 9 nines. It's better than anybody. That's great. I'm definitely getting a sleep tonight. However, there is some unstated assumptions here, which is that the probability of each of these houses catching on fire is independent. But in my neighbourhood, there's a really popular trend at the moment to use like kerosene, other flammable-based paints. Don't recommend it. And in my neighbourhood, there's actually a mutually assured destruction policy that if your neighbour's house catches on fire, guaranteed. Okay. So what I want to talk about is what happens when you have this kind of non-independent failure happening. So that means that if I've created a redundant system where I had a 1 in 10 chance of this catching fire, and now I've got 10, but if one goes, then its neighbours are going to go and its neighbours are going to go, right? Which is very similar to what I was talking about before. This is cascading failure, and it happens all the time, whether we want it to or not. So if the probability of an individual failure is 1 in 10, so that means the probability of it not catching fire is 0.9. So 1 minus 0.1, okay? So that's the probability of all successes, so all of these not catching fire, because if any one of them catches fire, they all go, is 0.9 to the 10. Okay? Okay, which if I multiply it out, it's about 65% chance that it's going to fail. Sorry, I've talked over that bit, but it's other way around, and then 1 minus that to get the probability of failure. So 65, I bought 10 houses, which, as in Sydney, is not that fun. I can't even afford one. It's 65% chance I don't get to sleep tonight. That sounds pretty crap, okay? So the last part of my talk is kind of about how we isolate failures a little bit. That's really important because we don't want this. We don't want this situation. So I took all the roofs off. Every microservice deployment ever. That's great. I don't know. I don't know if it's... Sorry if there's too many microservice jokes. I just went to Yale last year and it was epic. Can't get over it still. Yeah. So the first thing we want to talk about is timeouts and retries. Again, hopefully this is all pretty obvious to people. I'm just saying it out loud so that everyone feels comfortable saying it out loud to everyone else, and then it'll actually be a thing. So, timeouts. Other systems will almost always be your most vulnerable failure modes. I think that I say the opposite, which is always your fault, but I think that it's pretty reasonable to say that any external system you have is possibly most likely to be a failure point because it could fail, how you talk to it could fail, all sorts of things. You're basically multiplying their failure by your failure. So, never make a network call or go to disk without a timeout, right? You want to be able to handle these failures. If something's going to fail, make sure that you don't sit there waiting for it to not fail. So if I go back to that example at the start, EBS volumes were slow. There should have been far stricter timeouts on it. It should have failed. It should have not brought down an entire AZ. Pay particular attention to reusable and pooled resources. I guess this one is something that comes up in Scala quite a bit, in Java in general, is that there's a plethora of broken database JDBC connection libraries, all sorts of things. Just be really, really careful. Anytime you have a resource that's going to be reused that could already be broken, be very careful about it. Always have timeouts, always expire connections, recycle them. If they're broken, don't put them back in. Again, be really careful. And then back off requests that time out. So this one is a common mistake. People go, yeah, okay, timing out stuff. I'm going to retry things when they fail. And then they just keep retrying and make it break harder. So an Ambiata story, because they're the best kind, because they're actually real. But we recently had a situation which a language which is not Scala has an interesting default, which is that most timeouts are specified in microseconds and not milliseconds. And I have a fairly eclectic team. They've been doing Java a lot of them have been doing Java for a long time. A lot have been doing other stuff. And there was a little slight error made. And we accidentally had a back-off timeout of 200 microseconds instead of 200 milliseconds, which basically meant if we got one failure, then we sent as many requests as we could really, really fast. And as I said, we already have a slight penchant for breaking AWS. This did not end well. There was lots of other reasons for it as well, but yeah, back off, exponential back off, random exponential back off, random exponential back on. These are all terms, but these are things you should probably think about how you're going to retry. Yeah, heartbeats. This is a technique that is probably a bit grander than that word, but effectively, what I would like to get across is that if you know something is failing, fail fast. Okay, this can be done in any number of ways. So a really common and simple and easy way is that if you have some service, poke out some status API, possibly not to the outside world, but at least have some internal status that shows what version we're running, whether it's okay and all of its dependencies are okay, some stats internally. Sometimes, or quite often, this could be centralized, as in you could be pushing it out to some central monitoring service, or it could be distributed amongst all the services. But if you start collecting those stats, sort of things you can start doing is like, you see that these ones are starting to respond slowly, then you can kind of take them offline, right? And you don't have to shut them down. You can take them offline until they start recovering. Perhaps they just got too much load and then you can bring it back in. But that's a whole bunch better to take something offline that you know is going to fail, or you know is failing or not responding how you want, than waiting till it actually fails. We start sending errors back to the client, and then it starts requesting more, and you don't want to be hostage to your clients. Oh yeah, next technique, which is again pretty simple, is the concept of circuit breakers. This one is often more difficult to engineer socially than in code. The code technique's really straightforward, but socially is a bit harder. So the idea is that if I have some piece of code that depends on all of these different services, and then one of those services starts breaking, I want to be able to disable that part of my system rather than my entire system. So there are a few good talks. I think Yahoo and a few other people have done talks on this where they actually change their homepage based on what services are currently running. Like their uptime is terrible, so it's common that the ad server crashes or the little stock ticker crashes or whatever, and they just stop displaying it, and that's great for them. But that's a far better situation than taking yahoo.com down. So a real example you might have a user profile service, and because we're in microservice land, all of the profile is stored in one service, the list of friends is stored in another service, which means that the profiles could come back, but the friends might not, and maybe that's acceptable to you, right? So you might be able to say, look, this time, I'm just not going to return the list of friends. Okay? So what I was saying at the moment about this being, at the start, about this being more of a social problem, is that this requires fairly significant coordination and documentation. So the idea that you're sometimes going to return an answer is pretty useful. It's pretty easy when it's a human. But if you're writing like a HTTP API, it's actually far more difficult. So saying that I'm sometimes going to return this field, if I don't assume anything, that requires a fairly large that. But there are a few techniques that you can do when you're designing HTTP APIs. So instead of returning these fully populated blobs, you could return a URI that actually would let you go and fetch those friends, or a URI that would go fetch that profile rather than returning the whole service, which means that then it requires your client to make another call, which you can then fail or not, and then they could sort it out. So there are a whole bunch of ways around this. Yeah. Okay, almost done. Don't worry. Sorry. It's taking a bit longer. Okay, petitioning. This technique is really powerful, but basically the idea is that if you have two services, they both depend on the same thing. It's a really bad idea for them to depend on the same pool of the same thing. So if I get a traffic spike in service B, service A there, service B sends all of its traffic onto service C, and of course that eventually brings down everything. Again, it's pretty easily avoidable. Basically, we just want to divide this resource into two pools such that this one can definitely not take any more than half of it, say, and then this one survives another day, right? So this technique is more useful when parts of your site or parts of your API are not equally important. So authentication, probably important. I don't know, funny pictures, maybe not. Depends on your service, I guess, but just pool things. The other thing is that it's actually a good technique to do this inside of your services as well. So if you have a thread pool, have different thread pools for different reasons. Don't let a single thread pool of inconsequential things starve out a really important one. Yeah, it's all hopefully obvious, but I'm saying it out loud so that everyone takes it away. Another form of petitioning is dividing multiple types of requests up into different services. So one of the things is that back in my horrible service that had check and periodically check in, there was actually two API calls that were very, very different. One of them was this ping service, this check service. It was really fast, required no computation. There was also a download that actually downloaded the thick client. That means it was downloading hundreds of meg across internet all over the world. In Australia, obviously, it's going to take hours to download 10 megabytes. So this was really slow and painful. But what happened is that it was all coming from one server, which makes just operating this server extremely difficult. So we have a fixed thread pool. Are the threads going to go to a whole bunch of slow downloads and then not be able to respond to shout? Or am I going to start responding to too many shouts and not be able to download it all? These are all questions which can be solved just by splitting things out in some way. Cool. On to the last or second last one, which is back pressure, which again, is something that people say out loud. I'll say all the time. I just making sure that everyone understands exactly what it is. So I guess in a different way of back pressure is just saying that if you fail one request instead of saying failing all the requests, okay? Which means that if I can slow something down or slow down a producer, and it's okay to drop something or to push back on them, then that's great. Just say, look, you're getting throttled right now, slow down, request again in a second, which again supplies back into retries. But don't take on so much load that you're going to crash. So that works pretty simply. If we measure some slow requests, then we're just going to say, this upstream can start dropping requests and telling them to retry in a second, which is fine. The other part of back pressure that is a good idea, that it's not back pressure, but it's closely related, is to start tapering limits. So if your data start at the bottom, so if your databases can accept 200,000 dB requests, that's great. But you want to make sure that your servers are only accepting 50,000 requests. It's kind of hard to work out these ratios, but maybe there's on average 4 calls per service request. You don't want to have 200,000 server requests trying to make 800,000 database calls that you know you can't handle. And same, limit the proxy requests. So this is a form of back pressure. It's just not very elegant, which is that you basically just stop things early so they don't break everything. Yeah. So I guess to wrap up and reiterate everything is that failure is inevitable. That service that you're all forced to use, it's probably going to fail. You've probably seen it fail. You're probably building something that is going to fail. And when it does fail, it's probably not going to fail cleanly. It's going to crash something else, which is going to crash something else, etc. But all these things can be mitigated. So hopefully, I probably didn't give you enough information to actually do anything. Sorry. But hopefully I gave you enough information that you could go off and look at these things, think about them, research them, apply them in some context. I gave you some insight into something that we do concretely. Hopefully you can probably come back and do a talk about what you do in 6 months' time or 12 months' time. Overall, don't panic. It's always good. Don't panic. If you want some better advice than me, this book is exceptional in describing some of these patterns. Cool. Thank you.
Yeah. Awesome. Thanks, Mark. Questions? Anyone? Go. Oh, wait, sorry.
Oh, okay. Yeah. Whew. The pressure. Oh, yeah, look at that. Cool. So I built Aperture, which you can see that a new instance come up. It's just in our dev environment. So our in production live dev environment. So again, split. This is in production. I just say dev because that's what we call it. So a new instance came down, and then eventually an old instance came down. So you can see what took about 10 minutes for it to bring the new one up, and then about another 8 minutes to realise that it could take the old one down. So that's what should happen. There's probably not enough health checks and stuff on these services yet, but that's kind of what we're trying to do. So cool.
Cool. So I got a bit of an opposite question of your talk. So you talked about how we can make our APIs resilient, and potentially there are services which we're forced to use which may not be resilient.
Yeah, mine. Awesome.
So how can we? What techniques can we use to call the services which aren't necessarily resilient and we don't necessarily want to break, and bad things will happen if we break, like EC2? So I was in this situation recently where I had to call a service and I had to make sure I didn't break that service when I called it. So do you have any tips?
I might. I'll see if I can pull up a slide. I do. I think it's a really long answer. Maybe Lawrence should give a talk on it. But I can maybe have a picture here somewhere. Maybe. Funnily enough, the same chopstick picture. I think I have a picture here somewhere. I hope I do. Otherwise, I'm just wasting time. But yeah, look at this. So, worst library ever. I think this is what you're describing. I talked about this a while ago, but this was in the context of a crappy Python machine learning library. But it applies just the same to APIs. So there are techniques. This was to emphasize that crappy code exists. But there are techniques where, like, the probability of failure of this thing was like 80%. It's going to fail pretty much every time. But doing things, it also had a database and it corrupted it every time you called it, which is possibly somewhat related to what you're saying. Calling APIs is a lot harder than doing this one, but what you can do is build some proxy on top of the API, then build some reliable storage of your own. So this might have made more sense in my other talk, which was all about reliable storage. But basically, if you build up your own view of this service, and this isn't always possible, it's not always easy, and I'm not trying to pretend it is, but I think you eventually have to build a proxy. You have to have that cache, proc, and journal out entries before you get to the bad part. And then have that be something you can replay over time. Yeah. So then you could start running your own service. Maybe at some point you can replace it and not have to call it anymore, but enterprise, unlikely, I understand. I don't know if that's answering your question, but I think that there are ways to do it. They're never easy, though.
With a service like Baton, do you ever have any troubles with Baton causing cascading failures? Let's say it stops receiving heartbeats and takes your entire set of services down.
Yeah. It hasn't yet. I assume that it will at some point. I have a friend who told me a story the other day that we rely on tags on Amazon, tagging resources to tell us certain things. Not in this particular way, but I hope that, I don't know what company it was, so hopefully it's nobody in the room, but basically they relied on Amazon tags saying what to keep up, so they stored a lease as a tag on an instance, and then if the lease expired or they couldn't find this lease tag, then they had a thing like Baton that shut down the service, which is a very similar situation, and Amazon had a bug for 3 days that the tags always returned empty. Again, the status page was green, and they managed to shut down every machine in their infrastructure. So I'm looking forward to the time when that happens to my current setup. It will happen, I'm sure. Yeah.
Anybody else?
Hello. Previous company I was at, we really want to do the thing where we roll out a service and or you've got an existing service and you roll out a new version and you get rid of the old one. It's like, it's fantastic. The problem is though, we're encountering things like bugs where it would corrupt data in the database. Basically, there was a bug in the processing code, and it wouldn't take the service down, but it was a horrific bug. And so, we can't just roll the thing back. Now it's screwed. Yep. So does this only apply to certain kinds of services? How do you write things in a way that would make this sort of thing difficult to, screw up the data store you have, for example?
Yeah. That's a really good question. Hard work. I think that there's a few techniques that you can use though, which is all my microservice jokes aside is that splitting databases and data stores by kind of coupling starts to help, so that you minimize any corruption that happens. You start to minimize it. Then once you've started to minimize it, then you can start the idea that you could actually recreate a database. So in my ideal world, and this is not always possible, and Rob, who asked the question, is going to start working for me in a couple of weeks, so he'll know that it's not ideal, is that you should be able to store, have redundant storage, such that you have a journal of your requests coming in, you have your data store, then you have backups, and then you can literally, if you need to, roll your database back and then replay the journal on top. This only works if your data stores are fine-grained enough and designed well enough. And for historical reasons, that's not always possible. But slowly shifting your services in that direction is a positive thing, if not always tractable. Sorry if that's dodging the question.
It's another way of saying immutability changes everything, right?
Thanks,
really.
Jed.
Right, that's important.
You're right. You're absolutely right. My real talk tonight was meant to be on journaling file systems, so
Yeah.
sorry. Hopefully this was informative anyway.
Absolutely.
Cool. I'll stop talking and let Jamie
Cool.
do something.
All right, short break, and then we'll have Jamie.